All right,
So
Sam.
let me know.
We're ready to get
Are
tricky
we
with
ready?
it whenever you are, sir. We're recording.
Let's get tricky. So trigonometry, it's the basics. It's very simple, right? Like we have the basic equation, Pythagoras equation, where it's like a square plus b square equals c square. In this case, I use the x, y, and z. In this screen, you can see like basic triangle, and we're gonna focus on this angle. So trigonometry is about like studying triangles with a 90-degree, and later on you can apply the same rules to any angle, but we're gonna focus on squares because it's more simple. So the basic relationships are like sine, cosine, and tangents, and I think you know all of this. This is the basics on the song. So if you
What
look
was the
here, you
song?
will.
Was that Get Tricky with It by
Yeah.
William Smith?
Yes,
Okay.
exactly that song. So you have the opposite side, you have the adjacent side, and you have the hypotenuse, right? So the basics of trigonometry is sine of alpha is x divided by z. The cosine is adjacent side divided by z, and then the tangent is the opposite side and the adjacent side divided. And that is what we're gonna use to figure it out the Umbra. This we're gonna apply this lesson to calculate the Umbra of the eclipse in the sun and the moon, right? I will walk you through um, how to apply this knowledge, this formula, to the actual problem that we have. So this is one of those examples that you are like, but teacher, why do I need trigonometry for? It's like, here, I found a way to use trigonometry.
I found a way to force it into your life with relevance.
This is why it's relevant, right? So here's the information that you gave me. Tell you the information that we need, the basics, right? Our sun is the radius of the sun, which is the diameter divided by 2. And I'm using like freedom units. I think these are like miles. So we can change this in case any of them of these measurements are wrong, right? But first we need here you have the sun. So we need the radius of the sun. I cannot, but you see where my mouse is, right?
Yep.
So this is the
Yep.
radius of the sun. So with the radius of the moon, we have we need the distance uh, of the sun, so where the sun is, and the distance towards the Earth, right? Not towards the moon, towards Earth. So that's the distance of the sun, because we look at the sun and we measure from us to the sun, and then we measure from us to the moon, and we have this distance here, and then we have the radius of the Earth, right? So this is distance sun, distance moon, and radius of Earth, radius of moon, and radius of sun. So what we want to find is this line over here, right? That says Umbra. So this is a projection of the shadow of the moon on Earth. So like you see, all of these are triangles. So to find that triangle, we need to do some conversion, right? So the first thing that we need to find is the angle, because all of these equations says sine of alpha, cosine of alpha. So we need to find alpha. So what would be the easiest way to find alpha? So because trigonometric, this relationship, right? This alpha here is the same as this alpha here. So we can go and focus on this small triangle and find out alpha from there. So if you look at this small triangle, how I mean, how would you get the trigonometric function out of that triangle? So first, we have one side, we have two sides, and we have three sides, right, of the triangle. So
Right.
this side from here to here, how do you calculate this side?
Well, you would calculate for the opposite, and that would be for the opposite over adjacent, right?
No, but the
Or
actual measure of that side. So you have you have a measure in miles, right? How do you get that
for what side? The moon?
from here? So it's not the moon. It's from here to here. Right? We're gonna calculate this small triangle here.
We're calculating for the opposite.
So I'm gonna draw it here. We have the sun, and the sun have a radius, right?
Right.
And then we have the moon, and you have a radius. And there is this is a triangle. And now if you put the moon here, these two moon are not the same side, but they're supposed to be the same size, okay? You put the moon there and you make like this.
Would that just
So
be like Pythagorean theorem? Like a
yeah,
squared plus b squared?
no, we're gonna use the sine, cosine, and tangent. So we can use the sine because what I wanted to show you is like if you put the moon up here, you can easily calculate this line because this line is the radius of the sun minus the radius of the moon, right? You know the distance of the moon, the radius of the moon. You know the radius is this line here, small. I mean, I would make my screen bigger so we focus on it. But so the tricky part is trying to figure it out what alpha is. So to understand, to find out what the alpha is, we need two sides of a triangle. When we know two sides, we can find the angle, right? So if we want to find this angle, the easiest way that I found, maybe there's another way to find it, is to have this side over here and this side from here. So this side, the sun to the moon is the distance between the sun and the moon, right? If we know the distance from us to the sun and we know the distance from us to the moon, we can calculate how long is from the sun to the moon. We just need to take away the distance from we just make a, what is it called, subtraction.
Subtraction?
But
Didn't we already
yeah,
know the sun and the moon distance though?
yeah, we know the distance of the
Yeah,
sun and
that's
we know the distance of the moon. So we just subtract the distance of the moon to the distance of the sun, and then we get this line over here.
I thought we actually
Right?
looked up the distance between them. Couldn't we use that?
Yeah, but how do you get that distance? You don't actually measure from the sun to the moon, right? Because no one is on the moon to measure from the sun.
I guess not.
You just presuppose it.
Yes.
Exactly.
Yeah. And we presuppose it from the frame, the lab frame that we are on the Earth. This is a position where we are. That's what we measure from. So, so basically, this is one of the sides of the triangle. This one here, which is the distance to the sun minus distance to the moon. The other side that we can find out is this side here, which, like I was trying to say before, maybe it got a little bit complicated, but it's just the radius. This is the radius of the sun, right? And if you put the radius of the moon right here, you take the radius of the moon out of the radius of the sun, and you have this side, which
Okay.
it was an unknown. And now we know this one, and then we know this one. So we know the opposite side of the triangle, and we know the hypotenuse of the triangle. So now we can calculate the
so another
sine.
question.
Should.
When you put the moon inside of the sun and you're doing just the radius, the way that you have it, it's like it looks like you're using the diameter of it, but you're like technically you would have the moon halfway in the sun, right? Is that is it just
Correct. This
okay?
is the
Gotcha.
halfway.
Yep.
This is why I always put the mouse at the center of the moon, right?
Yep. Yeah.
But you're right. That can be
Okay.
confusion because it's the whole moon, but it's just the radius, right? So because from the center of the moon to the center of the sun is the
Yep.
side of that triangle.
Gotcha.
Right. So then what we do, like here, we need to find the angle, right? And the angle is alpha right there. So sine of alpha, I think I have it somewhere here. No, I jump steps. I'm very bad at explaining mathematics because I jump too many steps. I have a problem writing step by step. But basically, sine of alpha, it's what we talk about, the radius of the sun minus the radius of the moon divided by this distance to the sun minus the distance to the moon, right? This is one side of the triangle, and this is from here to here is the other side of the triangle. Now, what I did here is the arc cosine. Basically, it's the inverse of the sine, and I will show you the formula is up here. So you see the formula of sine, you know this, right? Or I will just go through it with you again. I'm sorry if it's repetitive, right? But like the sine of alpha
Sine is opposite over hypotenuse, right?
correct. And now the arccosine, which is the inverse of sine, what would be? It would be z divided by x, right? Instead of x divided by z, it's z divided by x. It's the opposite. So it's the same as if you multiply a number by 1, 1 to the minus 1. Does it make sense? So sine of alpha, arccosine of alpha is sine of alpha to the minus 1. So it's the same function. And that is what we're doing here. So when you do the arccosine of that, you will get this 0.05 radian, that's 0.2 degrees. So now that we have alpha, we can proceed and with the calculation, right? Then what we want to find out is the umbra. And the umbra is this line over here, this triangle line. So this is gonna it's just gonna get a little bit more complicated, but it's the same basic problem. So there is a point that is maybe inside of Earth, right? Because the umbra, that these lines are gonna maybe even pass through Earth, right? Maybe they are beyond Earth, or maybe they don't even touch Earth, depend on the position it is, right? But we need to figure it out the distance to the umbra, where the distance of the umbra is, right? So this is what's called the umbra. It's a distance from the center of the moon to the point where the two lines of light converge. That is what this inside here is umbra, right? Are you following me? Tell me if you're following.
Yes, I'm following.
You follow me. If you have a question, interrupt, okay?
Mhm.
Right.
Okay.
So to find this distance of umbra, it's another triangle, right? And we can find it very easy because it's from the moon. We already have this distance, which is simply the radius of the moon, and then we have the distance of the umbra. This is what we want to find out, and then we have alpha. So we already have the angle alpha. So knowing the angle alpha, we can easily derivate and find the distance to the umbra.
I have a
Right?
question.
Yep.
How did the distance on the moon right there correlate to the distance of the moon, like on the sun? Because it shouldn't it be like kind of triangulating in that diagram?
Here, where I am right now. Come again.
I mean, I'm just trying to figure out how you're saying those would be equal if whenever the shadow is being made, it would be triangulated to be smaller. Maybe
You're
just
talking
continue.
about no.
Just
You're talking
continue.
about the Umbra. No, no, no. You
Yeah, I'm
have the
talking about the
question.
Umbra.
You're talking about the Umbra, right? What about
Mhm.
the Umbra?
I think that the fact that the moon is right there on top of the sun kind of confused me
Up
to like
here.
thinking,
No, this
yeah,
is just a representation. The moon is up here. The moon is here, right?
okay, yeah. I was just a little bit.
This is just to visualize, to take away this radius
Oh,
here,
okay.
right? That was the only purpose to having the moon here. But the
I
actual
get it.
position of the moon is here, right? Yeah.
Yeah. Okay, thank you.
No problem, Taylor. Remember, there's no stupid questions, only stupid people. That was a joke.
That doesn't make me feel better at all.
It was a joke, Taylor. All right. Here we go. Where were we? We need to calculate the distance to the Umbra, right?
Yep.
So we have the radius of the moon here, and we're gonna calculate the distance to the Umbra, and we have the angle, alpha. So what we're gonna do is to say, okay, for example, it could have been sinus or it could have been cosinus or whatever, right? But because we have the distance of the moon, and this is the opposite of the triangle, right? And we need to find the hypotenuse. So that's create a sinus function, right? So this side of the triangle is radius of the moon, right? So radius of the moon, and then divided by the umbra, the distance of the umbra. So that's the sine of alpha. Now we know this and we know this, but we don't know distance of the umbra. So you can just switch it, right? You can move this one here, and you can move the sine of alpha down there, right?
Yeah.
And this is what you get. Distance of umbra is radius of the moon divided by sine of alpha. And that gives us this result here. I don't know how many miles that is, but that is not that important, right? The number. What we're looking for is the actual methodology to follow that. So now we have the whole distance to the umbra, and we move to the third part of the exercise. We have this line here with, from the moon to the distance of the umbra. We have that. We have the distance of the moon. So you see what I'm putting my mouse, right? So these lines here, the moon and the umbra. And then we have radius of Earth. And now we're gonna focus on this triangle over here.
Okay.
So because the the distance that we're looking at is here, is this little bit of the triangle, right? This is what actually is the shadow. Like the moon is giving this umbra shadow on Earth, on the surface of Earth. So this is the triangle we're looking for. So how do we get that triangle? So so if you look here, I'm trying to find an easy way to.
Yeah, it seems very difficult.
No, it's simple.
On the computer to demonstrate?
Oh
Is that what
yeah,
you're
but
trying to do? Yeah.
yeah. But the thing is, like, mm, I I just want you to visualize it. I'm not trying to overcomplicate stuff, right?
Hmm.
So if we want to calculate this side, this is our incognito, right? This is the side that we try to solve. We have the angle, and then we're gonna use this little side of the triangle, right? From here to here. So what is actually this side of the triangle? How do we calculate that? Well, that is basically the distance of the umbra minus the radius of Earth. So we take the radius of Earth minus the distance to the moon. So if you take away the distance to the moon, this is umbra minus the distance of the moon, and you take away a radius of the Earth, it's basically that distance. I'm trying to find a better way to visualize that. I don't know. Do you see it? What I'm talking about?
Yeah, it looks like the same relationship you did with subtracting the moon diameter. Or the moon the moon radius.
Exactly, but I don't know if you can see it. Like I'm trying to put it in the simple term, right? Because it's like this is the distance of the umbra, this is the distance of the moon, and then you subtract each other, and then you add this bit, the radius of the Earth, basically. So
I mean,
look at
I
it.
see what you're saying.
Yeah, look at it in a different way, right? This is the distance of the umbra, right? And we're trying to find from here to here. The distance of the umbra, you take away the distance of the moon, you take this one away, and then you have this triangle here, right? And now you add the radius of the Earth, and then you have the whole side of the triangle. Maybe that's the best way to show it to you. You
Yeah,
see what I'm
because you have
saying?
to exactly. So you're gonna have to basically calculate it to the end, but then subtract it out because you're not going to the
Exactly.
very point. Yeah.
Exactly. So you have the whole distance from the umbra up to here. Well, you take away the distance from the moon, and then you have these little bits. But now it's missing this side here, so you need to add that. So that's basically okay. Now we have the value of this side of the triangle, and now we have the angle, and then we can calculate this side, which this is the opposite of the side of the triangle. This is the adjacent part of the triangle, and you have alpha. So this is tangent of alpha, which is you use the tangent of alpha is the opposite divided by the adjacent. So then we put that into the equation, and we say the tangent of alpha, it's S umbra, which is this side of the umbra, divided by that big side that we talk about, and then we rearrange that organization. We just switch it. So this side goes to this side, multiplying. So you know how to do this equation, right? When you have this kind of equations, if this is dividing, you can flip it to this side of the equation, multiplying, right? So you get S umbra is equal to tangent of all of these that we talked about before. But now, because we are only calculating this side, and we actually need both sides, I guess this is the diameter of the eclipse of the umbra side. Or if you don't put a 2 here, then you got the radius of the eclipse of the umbra, and this would be our final result, like 168 miles for all the information that we use, right? Taking in consideration that the distance of the sun is this, the distance of the moon is that, and the radius of the earth is this. So that is basically how you break it down in terms of like trigonometric to calculate the Umbra. So was it too overly complicated, or you could follow through?
Oh, it's totally fine. I think we should try to do the calculation now.
Well, the calculation is done. It's this
You
one.
already did it,
168.
Taylor.
Well, where's the number? I don't remember you actually doing the.
168 miles.
Yeah, it's done
That's
automatically, right?
Yo, Sam, that
Oh,
was dope, bro.
hold on. That was different than the other ones we got too. 168.
Mm.
Okay, that was a good presentation, dude.
Really?
That was
I saw
amazing,
this.
Sam. Thank you.
Happy. I didn't think I did do well with my first presentation, so hopefully I will do better next time. But glad you guys could follow through.
Oh, you crushed it, bro. It makes a lot more sense than it did before, and I especially like the inverse relationship. Breaking that down was extremely helpful because I only learned
Here, arc sine and arc.
the arc sine. The inverse was great understanding that.
This is very simple. It's exactly the same. It's just the inverse. And what is the inverse of a number? Just flipping the denominator by the numerator by the denominator. Just flipping around. That's it.
Yep, it's badass. Thank you, sir. Is there any further questions, Taylor? If not, just go ahead and
Sorry, my thing
sing.
was-
Yeah, you're good.
Hold
If there's no
on.
further questions, just sing Get Triggy with
I
it.
do have a further questions.
Okay.
And then we'll do that
Okay,
after.
shoot.
Did the curvature that you know how the shadow is being projected on a curve technically, would that affect the size of it?
Yeah, but like in every single book on Earth, we ignore curvature because you cannot perceive it.
GG. All right. Very cool. Yeah, so they just cosine all of that and don't. Sam, how funny is that? They cosine all of that and they're like, "Yeah, we're not gonna spherical access it because it's not even real." Dude, no, man, these guys, dude, are you serious? Are you serious?
But if you actually do the cosine,
Oh,
that is like negligible. So ignore it.
Right, right. It's just flat enough to always work for that. But when we do our stars any measurements, that's where. Oh my god! All right, dude. Fantastic prez, man.
Thank you, man.
Is the 168? That's in miles, right?
In miles. Yeah, I think I put all of these numbers in miles.
Freedom miles, Taylor.
Yes, freedom miles. And this one is degrees. So the angle alpha is a very small angle, right? Because it's just, this is exaggerated to an extreme, right? Because the sun is very, very far away, right? So this angle is very, very small. So it's so small that it would seem like it's almost like parallel lines. But
So why did the AI every single time get it wrong whenever I just put in the raw credentials of the measurements of each?
Because it's not designed to do that stuff.
Yeah,
for you for free. Like,
yeah, I think it was one of the steps here when we're doing this trigonometric. Like there was 3 steps. Maybe it was jumping around one of the steps here with the Earth, trying to calculate the Umbra. I don't know. I cannot say for sure because I couldn't see what the AI is doing. But I think this is a most accurate way because you can understand this is trigonometry, right? There is nothing here that is missing in a way, right? The only assumption that you could make wrong is the actual position of the sun, like what day of the year are you looking at? So because it changes, right? And what day of the month is taking place. So you have the precise location of the moon and the sun in the whole sphere, right? And when you have all of that very precise, like, this day 152 of the year. So you know that the distance of the sun is going to be this specific distance. So you can put that here, and the same with the distance of the moon, and then you get a more accurate Umbra.
Yeah, that's crazy. I wonder why, they were way off. They're like 1,000 miles, like the answers that AI would give me. Crazy. but I'm glad you did
And
it. Thank you, Sam.
What is the real Umbra that you get? Or if you get the information about the real Umbra, is it close to this number?
It's like 60 miles. Oh, let's see. It's Umbra. Yeah, like it told me 60 at one search and it says up to like 100. So I don't know. I think it could vary depending on where it's actually at.
Right.
But whenever I put in those raw values in AI, it tells me like 1,000 something is what it should be trigonometrically. I don't know how that happens, but I'm glad you explained it. Thank you.
No worries.
Well,
All right.
I'm extremely disappointed that you just use regular cosines for this and you don't use hyperbolic ones for spheres. I'm actually like, I'm so sad. That's heartbreaking.
Hyperbolic cosine. I mean, I see what you're saying. Yeah. I didn't want to complicate things more. I was looking inside, you know.
No, you're
the
good.
inner angle.
You're good. You're good. I'm just fucking around.
Okay.
Well, all right.
Okay.
Great prez. All good, Taylor?
Thank you.
All good. Thank you.
All right, cool. Now we're going to get tricky with it and watch the trig song. I'm just kidding. I won't put you guys through that again.
Getting tricky with it.
Yep. There it is. That's the rendition we'll go with. All right.